Welcome to Solution to Problems for the class. This is the practice that we are going to do. So we are going to solve 10 problems. The first one is here. Find the integral from x plus 7 ddx. What is asking is find g of x giving f of x equal x plus 7, who is g of x, that when you make the derivative of g respect to the x will give you x plus 7. This is what is asking the problem. So we know what is g of x. G of x must be a function whose derivative is f of x. What is the function whose derivative will produce the x? X squared divided by 2. And what is the function that will produce a 7? Well, 7x. Now we can check. G prime of x will be the derivative of g of x. The derivative of 2x squared is 2x divided by 2, which is x. And the derivative of 7x is 7. So g prime of x is f of x. Is this one the general solution? No. If you add at c here, it will be also true that g prime of x is equal to f of x because the derivative of c is 0. So the conclusion is, given f of x equal x plus 7, the g of x should be x squared divided by 2 plus 7x plus z. This is the solution. Now, second problem. Find the integral 2x minus 3x squared ddx. Again, given f of x equal 2x minus 3x squared. The problem is asking who is g of x that when I make the derivative, I will obtain g prime of x equal 2x minus 3x squared. And the answer is being done using the power rule. So we now use the power rule. And we'll do it like this. The integral of 2x minus 3x squared ddx, the integral of a sum or a difference, if the integral of the sum or the integral of the difference, 3x squared ddx. What is the antiderivative of 2x? Is the function that when I make the derivative, I will obtain 2x. This is x squared. What equation I'm using? The power rule. What is the antiderivative of 3x squared? The antiderivative of this function, 3 of x squared, is a new function whose derivative is 3x squared. Which one is? Is 3x cubed divided by 3. Why? Because if I make the derivative of this function, it will be 9 divided by 3. 1 3 will cancel. So it will be 3 by 3. The derivative will be 9x squared divided by 3, which is 3x squared, which is this one. So I found g of x. Who is g of x? G of x is the function x squared minus x cubed. And that's all? No. Plus c, because when I make the derivative, the derivative of c will be 0. Let's go to check. What is the derivative of g of x? The derivative of g of x is 2x minus 3x squared plus 0. Is this f of x? 2x, yes, 2x, 3x squared minus 3x squared, yes. So the problem is done. And the solution is that g of x is this function. This function is the function that when I make g prime of x, I will obtain f of x. Then, as a conclusion, the integral of 2x squared minus 2x minus 3x squared ddx is x squared minus x cubed plus c. So this is the result. Let's go to the other problem. Now again, what is asking? It's asking what is the antiderivative of the function f of x equal x plus 6 divided by square root of x. Or in other words, what is g of x in such a way that g prime of x, or the derivative of g respect to the x, will be exactly f of x, will be x plus 6 divided by square root of x. So we know that the derivative of the sum of two functions is the sum, we know that the integral of the sum of two functions ddx, the antiderivative of the sum is the antiderivative of the first plus the antiderivative of the second. Let's go to use this thing. So the integral of x plus 6 divided by square root of x ddx, remember that I can split the numerator. So, but I cannot split the denominator if something is here. I can only split the numerator plus the integral plus the antiderivative of the function 6 divided by square root of x ddx. So this will be the integral of x divided by x raised to the 1/2, because the square root of x is equal x to the 1/2 ddx plus the integral of 6 divided by square root of 1/2 ddx. And by we know the rules for exponents, and x divided by x raised to the 1/2 is the same that x multiplied by x minus 1/2. So this is x raised to the 1, and the product of is x raised to 1 minus 1/2, or x raised to the 1/2. So what I have applied is that x to the n multiplied by x to the m is x to the n plus m. Always this rule for exponent will be conserved. So x divided by x is, so the first term, this term, I can put it like x 1/2 ddx. And this term, I can put it 6 by x minus 1/2 ddx. Now I can apply the power rule that say who is the antiderivative of x 1/2. The antiderivative is x 1/2 plus 1 divided by 1/2 plus 1 plus the antiderivative of x minus 1/2 is x minus 1/2 plus 1 divided by minus 1/2 plus 1. So plus c. So it will be x 1/2 plus 1 is 3/2. 3/2 divided by 3/2 is 2/3 plus 6 times x minus 1/2 plus 1 is plus 1/2 divided by minus 1/2 plus 1 is plus 1/2 divided by plus 1/2, so the 2 will go up, so the solution, the final solution would be 2/3 x 3/2 plus 12 times x 1/2 plus c. So this is the g of x. This is the antiderivative of the function f of x. It's a family of functions. So I can check now. I can make the derivative of g of x, of g respect to x, and prove that this is f of x, and prove you that this is x plus 6 divided by a square root of x. X plus 6 divided by a square root of x. So I leave you to do it. Do it. So our final conclusion here is that the integral of f of x dx is g of x plus c. So f of x is x plus c divided by square root of x. So we make the antiderivative, the integral is the antiderivative of this function, and the antiderivative of this function is this function. And we have proven that if we make the derivative of g of x, g prime of x, we will obtain f of x. Okay, to do these new problems, what the thing that I will apply? The first thing is I can split the numerator, so it will be x raised to the 2 divided by x raised to the power 4 will be 2x divided by x4 and minus 3 divided by x to the power 4. So I split the numerator, and I have the antiderivative of this function f of x is the sum of the antiderivative of each component of the function. So I will have the f of x is x squared plus 2x minus 3 divided by x raised to the 4. And don't forget, I want to find g of x in such a way that when I make the derivative of g of x, I will find f of x. So let's go to do it. The antiderivative of x squared plus 2x minus 3 divided by x raised to the 4 is the antiderivative of x squared divided by x to the 4 ddx plus the antiderivative of 2x divided by x to the 4 ddx, the antiderivative of the function, minus the antiderivative of the function 3 divided by x raised to the 4 ddx. So if I solve here, this is the equation, this is x raised minus 2 ddx plus 2 times the antiderivative of x raised minus 3, because x divided by x raised to the 4 is x minus 3. Or, if you prefer, x divided by x4 is equal x multiplied by x minus 4. And I apply the sum of the exponents will be, the base is x, and the sum of the exponent is 3 minus 3. So this will be the antiderivative of minus 3, and this will be minus 3 by the antiderivative of x minus 4 ddx. Now I can apply the power rule. We'll say x minus 2 plus 1 divided by minus 2 plus 1 plus 2 times x minus 3 plus 1 divided by minus 3 plus 1 minus 3 times x minus 4 is minus 3 divided by minus 3 plus c. Oh, so it will be minus 2 plus 1 is minus 1 divided by minus 1 plus 2 times x minus 3 plus 1 is minus 2 divided by minus 2. Minus 3 will be plus, and still minus 3 will be plus 1, and x minus 3 plus c. So it will be equal minus 1 divided by x plus minus, because plus with minus is minus 2 divided by 2 is 1, so it will be x minus 2. But x minus 2 is 1 divided by x squared plus 1 divided by x cubed plus c. So the function g of x, that when I make the derivative will be f of x, is this function. So we may check who is g prime of x. G prime of x is the derivative of 1 divided by x is minus 1 divided by x squared, so it will be plus 1 divided by x squared. The derivative of x 1 divided by x squared is x minus 2 2 times x, 2 times x minus 3, and the derivative of x minus 3, so let's go to put it in a more comfortable way. Well, let's go to put it in a more comfortable way. So I did a mistake. So, okay, let's go to put it like this. So the g of x is minus x minus 1 minus x minus 2 plus x minus 3 plus c. Now we can do the g prime of x. G prime of x is plus x minus 2 plus 2 times x minus 3 minus 3 times x minus 4 plus c. And this should be equal to f of x. Let's go to see if we made a mistake. F of x is x squared divided x squared plus 2x minus 3, x squared plus 2x minus 3 divided by x raised to the 4, x raised to the 4. So this is x squared divided by x4 is 1 divided by x squared, so I found the first term. Plus 2 times x divided by x4 is x divided by x3, so I found the second term. And minus 3 divided by x to the 4 is minus 3x minus 4, so I found the third term. So I didn't make a mistake. Well, indeed I did a mistake, and the mistake is here because when I make the derivative, the c will be 0. Let me correct. And this is 0 plus 0. And now it's f of x, okay? Sorry. Now this problem you can practice. It's the same idea. The same idea exactly. The integral of cosine of x, or the antiderivative of cosine of x, is sine of x. And the antiderivative of sine of x is minus cosine of x. So see how we did, and check that g of x will be this function. G of x is the function where the integral, the antiderivative of 5 cosine of x plus 4 sine of x ddx, the will be 5 sine of x minus 4 cosine of x plus c. Or in other words, the integral, the antiderivative of the function f of x is the function g of x plus c. And this is what we found. Let's go to the next problem. The next problem is more or less the same thing, only that we want to understand that the variables x or theta, they are mute variables. The integral of x dx, which is x squared divided by 2 plus c, is the same integral that theta by d theta, which is the integral, the antiderivative is theta squared divided by 2 plus c. The c, the theta and the x, they are mute variables. So we can do this kind of integral. Here theta will represent an angle, of course. So we can do a function f of theta. Now the function is f of theta equal theta squared plus secant square of theta. And we want to find the antiderivative. We want to find g of theta. The g of theta that when we make the derivative of g of theta, we'll find f of theta. So how we will do is exactly the same as we did before. This is two functions, f of theta and g of theta. There are two functions here. The antiderivative of the sum is the sum of the antiderivative. Okay, so it will be the sum of the first plus the sum of the second. The sum of the theta square will be theta cubed divided by 3. And the secant square, what is the function whose derivative is 1 divided by cosine square of theta? If you remember, is tangent of theta. So the problem is being solved by saying that the solution, the antiderivative of this function, f of theta is theta cubed divided by 3 plus tangent of theta plus c. And always you can check. Always you can take g of theta and make the derivative of g of theta, g prime of theta. And g prime of theta have to be f of theta. So in our case, g of theta is the function theta cubed divided by 3 plus tangent theta plus c. And what we want to prove is that g prime of theta, the derivative respect to theta of g of theta is f of theta. F of theta. You can prove it. Okay, you can do it. If I do the first derivative, theta cubed divided by 3, the first derivative would be 3 theta squared divided by 3, and the 3 will cancel. You will have theta squared, and the derivative of tangent of theta is secant squared. So the problem is done. So in this problem, problem 7, they say the derivative of a function is 6x. And the value of the function at x equals 0 is 8. And what it's asking is who is f of x. We know who is f of 0, but who is f of x? So the equation that they are giving us is that the derivative of f respect to x is c of x. And they are asking us who is this f that when you plug in the f and you make the derivative of f, you will find 6x. So who is f of x whose derivative is 6 of x? It's clearly the f of x, the function that I have to plug in here to be possible that the derivative is 6x, is 6x squared divided by 2 plus c. But c divided by 2 is 3. 3x squared plus c is the function. But we don't know the c, but we know the information about the point, the initial point, when x equals 0, f of 0 is equal 8. So we'll plug in this information on the f of x. This is f of x. Okay, we plug in the information. F of x is 3x squared plus c. When x equals 0, I will plug in f of 0. 3 by 0 is 0, 0 squared, plus c. And the problem says that f of 0 is 8. So f of 0 is 8. So 3 multiplied by 0 squared plus c is 8. So 3 by 0 is squared is 0. So c is 8. So the final solution is that f of x is 3x squared plus 8. Okay, let's go to solve problem number 9. And it say like this. It say a ball is thrown vertically from a height of 6 feet from the floor. So the ball is initially having a velocity up, of course, of 60 feet per second. How high will the ball go? So the initial conditions are that the ball is thrown at 6 meters from the floor, up to the floor, plus 6 meters, with a velocity pointing in the positive direction. So this is the y direction, and the positive direction is going in the direction where the numbers are increasing. So 6 feet, 1, 2, 3, 4, 5, 6, and the velocity is going in the direction in which the numbers are increasing. Okay, so these are my initial conditions. And there is another law that says that the acceleration, which is the change in the velocity per unit of time, or the derivative of the v, the velocity, respect to time, the velocity is 10. But indeed, I made a mistake because the velocity is not 10 meters per second square. 10 meters per second square because they say 6 feet and 60 feet. So, not to change this, we are going to imagine that this is 6 meters and the velocity is 60 meters per second. Okay, we change the unit of feet by meters. So now let's go to erase here 6 feet, 60 feet, and 6 feet. So the initial conditions are 6 meters. I'm sorry that I did with the 10 with minus 10. So the acceleration is going downwards. It's going in the direction where the numbers are decreasing. So the acceleration is minus 10 meters per second squared. What it means minus 10 meters per second squared? It means minus 10 meters per second in every second. So the change in the velocity occur as a constant rate of 10 meters per second minus 10 meters per second in every second is decreasing. So the equation that we have to solve is minus 10 equals the derivative of v respect to t. Who is v? V is, who is the function v when you make the derivative will be minus 10. Now, when you make the derivative respect to the t, the function v is minus 10t plus c. Plug in the initial condition that v at t equals 0. V of 0 is equal 60 meters per second, means that 60, I put 60 here, equal minus 10 by 0, because the initial time is 0, plus c, so I get that the constant c is 60. 10 by 0 is 0, c equals 60. So the velocity v of t is minus 10t plus 60. Now we go to the second part. What is the y, the position vertically? V of t is the derivative of y respect to t. This is the velocity, is measured in meters per second, and the velocity is the change in the position y respect to time. It's how fast the position is changing respect to time. So the equation that we have obtained from this differential equation is that v of t is minus 10t plus 60. So now we do exactly the same thing. V of t is minus 10t plus 60, and we wonder, who is y whose derivative is minus 10t plus 60? So the derivative y of t should be minus 10t squared divided by 2. If you differentiate this part, you will obtain minus 10t plus 60t. If you differentiate 60t, you will obtain 60 plus the constant c. If you differentiate c, you will obtain 0, and here there is a 0. Okay, so who is y of t? Y of t is minus 5t squared plus 60t plus the initial condition c. What is y of 0? Y of 0, the problem say that is also 6 meters, is 6 meters. So the c have to be 6, because if y of 0 is 6 at t equals 0, and this is the equation that I have for y of t, if you plug in t equals 0, you will obtain an equation that will say like this: 6y, 6, equals 0 plus 0 plus c. So c equals 6. So this is the equation for y of t. But this is not solving the question that the problem is asking. The problem is asking, how high will the ball go? I have the two important equations. The two important equations are that the v of t, the velocity, is minus 10t plus 60. So the velocity is doing like this. The velocity is doing like this. V of t at t equals 0 is plus 60. As he going up, the velocity decrease and decrease and decrease until it arrives to 0. When it arrives to 0, this is the velocity. When it arrives to 0, at this point he is at the maximum height. So the velocity decrease. Start at 60, decrease, and v of t is the initial velocity, 60 or minus 10t plus 60. As t goes, the velocity decreases. Okay, so when the velocity will be 0? When the velocity will be 0, we are at this point. When the velocity is 0, at what time the velocity is 0? So we put 0 here, the velocity is 0 minus 10t. So t is 60 divided by 10, so at 6 seconds, at the time t equals 6 seconds, the velocity is 0. Now we use the second equation for y of t, and we plug in y at the time 6 seconds. If you plug in at the time 6 seconds, you will find that it's 186 meters. So the ball, it will be at the maximum height when the velocity is 0, and the altitude will be 186 meters. So we discover the equation that governs a motion with constant acceleration. When the constant acceleration happens, a is constant, a0 is the derivative of v respect to the t. So if we wonder who is v of t, whose derivative is a constant, is this function v0 plus a0 of t. If you don't believe me, you make the derivative here. The derivative of v of t, the derivative of v respect to t, is the derivative of b0, 0, because it's a constant. The derivative of a0 multiplied by t, a0. So this equation is the same than this equation. So for a motion with constant acceleration, the velocity is this equation. And now I do it again, the same arguments. The velocity now is the derivative of y respect to the t. Now the velocity is v0 plus a by t. A is minus 10 10t. So what I'm going to find is that who is y of t? Y of t is the function of time that when I make the derivative, I will obtain v0 plus a of t. So it will be v0t plus a t squared divided by 2 plus a constant, and the constant is y0. So the two equations that govern a motion with constant acceleration are this one, and this, 2. Two equations to govern constant with motion, with constant acceleration. Now this problem 10, is more or less the same idea. In this problem they say, with what velocity, initial velocity, you should launch a body in the presence of a constant acceleration. Now I will do it right. The constant acceleration is minus 32 feet per meter second squared. That is equivalent to minus 10 meters per second squared in units of feet. So I will work with feet. Okay, and time in second. Okay, so it says you throw upwards a body with an unknown the initial velocity, and it has to arrive to 550 feet. What is this velocity that makes possible to arrive at least to 550 feet? So when it arrives, the velocity at the 550 feet will be 0. So now you say exactly the same. If a is constant, and a is the derivative of v respect to the t, is because v of t is a by t plus a constant that is v0. Okay, so v of t is v0 plus a by t. So v of t is v0, that I don't know, plus a is minus 32 feet per second square, multiplied by t. When the velocity is 0, the object is at the higher point of 550 feet at the top of the Washington Monument. When the velocity is 0, 0 equal v0 minus 32t, and this allows me to find t. So t is v0 divided by 32. So I have the time that elapsed to arrive the body to the highest point of 550 feet, but I don't know the very initial velocity. So from the equation y of t equal y0 plus v0t minus a divided by 2t squared, this equation comes from the fact that v of t is the derivative of y respect to the t. So we wonder who is y of t whose derivative is a by t plus v0. And we found that y of t, the function that we have to plug in here, that the derivative is a by t plus v0, is a/t squared divided by 2 plus v0t. If I make the derivative of v0t, I will obtain v0. If I make the derivative of it squared divided by 2, I will obtain it plus c. And this c is y0. So the equation is y of t equal y0 plus v0t, unknown v0, minus, because the acceleration is minus 32, I can put here a plus from now, and later on when I plug in the number, I will put the acceleration minus. So 550 equal y0. What is the initial height? 0. You start from here, from the floor, 0. Plus v0, unknown, by t. T is v0 divided by 32. this V0 divided by 32 minus 1/2, A is minus 32, this is this minus sign, by T squared. T squared is V0 squared divided by 32 squared. Plugging numbers and solving, you will obtain that the result is that V0 should be equal to a square root of 32 multiplied by 2 by 550, which is, I don't know, 186 feet per second. And this is the initial velocity that you have to launch a body from the floor to be able to move with a constant acceleration going downwards, A of 32 feet per second square, to move in a field of constant acceleration to arrive to 550 points. And the problem is done.